It's my pleasure to introduce Serena Eng of Columbia University. She has worked on time series analysis and I think what we could fairly describe as big data in economics. Today, Serena will be telling us about 6 terabytes of data from cash register scanners.
Okay, it's a great pleasure to be here, and just want to thank David for inviting me to participate in this event. So loosely translated, the title can be read as what does high-frequency economic data tells us about macroeconomic conditions, okay? So the high frequency here is weekly. I'm not in financial data world. So this question came up at lunch. If we have more data, is it of any help to economic policy maker? So to understand this high frequency data, I thought it would be useful to step back and look at what is the conventional data we work with. Okay? And so here is a series. It's the housing start series. Okay? It's monthly. So what you see, this is from 1960 to 2010. So you see the housing. There's a housing cycle. This is housing starts. Okay? It goes up and it goes down. And most noticeable is that 2010 big dip when we had the when we had the housing bust. Okay? And there was a housing boom in the 70s, and there was a housing bust in the 1990. And what's shaded there, these gray bars, are what we call NBER recession dates. Okay? So those are officially recognized to be recession by the government. Okay? So the definition of a recession is not universal, but in the US, there's a group of people that sat down and decide we are in a recession and we are out of a recession. Okay? Now, the point here I want to emphasize is that this data is only for one sector, it's the housing sector. Okay? So what is called a business cycle is actually not movement in any particular market, in this case, housing market, but it should be broad-based. It should be pervasive. Okay? So if there was a bust in the housing market, we don't care as much as if there was a bust in the housing market, in the labor market, in the oil market. It's broad-based. Okay? So what we are after then is actually looking for movements in this series across many series, not one series. Okay? So traditionally, what we look at, we usually look at 1 or 2 series before maybe 1980, 1990, and then methodology, econometric methodology improved, and we started looking at 4 series. Okay? And so fast forward a little bit to maybe year 2000, we started looking at 100 series, so that for us was big data. Okay? But I do have data from 1960 onwards, so I have a lot of time series information. The second thing I want to draw to your attention is that this is monthly data. It's about as high frequency as you usually get for data released from the government. Okay? And more often than not, we actually use quarterly data. And in fact, even when the government released for us data for the 4th quarter, which was December, what they're actually releasing is information for the previous 3 months, because it takes time for the government to collect data. Okay? So the conventional way of collecting data is you do a survey of government, go out and estimate what is the value of consumption, what is the value of output. They're not actually transactions based. Okay? A third point I want to make with this graph is that this is cleaned data. Okay? And by cleaned data, I meant that the data has been seasonally adjusted. Okay? This is housing starts. Housing activity is much more active during summer months when we can actually build. Okay? So I will later show you what happens for a series that is not seasonally adjusted. And when the government do the seasonal adjustment, they actually have this is adjusted by the census. There's a whole army of people, hundreds of statisticians hired just to clean the data for us. Okay? So the convention of doing time series work like this is fairly straightforward. I go to a website, I download the data, I model this data, and that's it. Because all I have to do when I analyze my 100 series is just to compress the information, to do a signal extraction of the 100 or so series I got. Okay? So now big data is in fashion, and then, and in business cycle is really about co-movements in a lot of series, so big and many, that sounds like a good thing, and we want to combine the 2 ideas together. But as a matter of fact, economists have been using a lot of big data even before the internet age. And I would say big data pre-Google, loosely speaking, are all these data collected in a survey. PSID, for example, is available quarterly. CompuStat may be also quarterly. So we have a lot of detailed information about households or firms, but the frequency is very low. Okay? So if you are in the business of monitoring economic activity, data coming at annual or quarterly frequency is not very useful. Okay? However, importantly, this data are fairly ready for use. Okay? So there's usually somebody responsible for this data set. Okay? If something goes wrong, I go and complain to that somebody. So as I mentioned before, in the type of work I do, we have actually gone from a small series to larger number of series, and big for me has always been like 100, 200. That was already creating a lot of work as far as asymptotic theory goes. Okay? So econometricians are actually very rather theoretically based. The big data post-Google, as you all know, is data. A lot of the data are not collected intentionally. Okay? Some comes from Twitter. People have used Twitter data to construct, use the Twitter data to construct a index of unemployment flow to get a sense of where the market is moving, very much like the Google food trend data, but from the point of view of unemployment. Okay? There's, of course, the transactions data from eBay, from auctions, from Spending Pulse, and, of course, the web search. Okay? And a lot has been talked about this type of scanner data that I have, which is when you go to a store, you make a purchase. It has a barcode. Every time it checks through a barcode, that is scanner data. Okay? So the question is, what is that scanner data useful for doing what I do? Okay? So I'm not the first person to use the scanner data. In fact, I was brought to my attention by my colleague who was interested in using the scanner data to develop some economically ideal indices. Okay? So before I go on to tell you what I want to, how I got interested into this data, I should mention that this type of scanner data also has a social use. Okay? So, and as example is in Japan when they have the earthquake. Yeah, it was earthquake or tsunami? Tsunami, right? Tsunami. Okay. So pretty much the traditional way of collecting data was disrupted. Okay? So this way of using scanner data was one way to give us a sense of what was economic activity during that period of time. Okay? A second use was to cross-check official data. Okay? So Argentina's official data was not terribly reliable. So you now have a separate cross-check to get a sense of economic activity. Okay? So how do I got into this data? Well, my colleague knew I was into big data in the sense of 100 series, so he asked if I would be interested in looking at bigger data. And what he gave me was access to the Nielsen scanner data, and this is the same Nielsen survey that collects the data, and it was provided for academic research 2 years after the fact. So this is not real time, but if you pay for real time of the data, it actually is available. So the first batch of data that was available to me was from 2006 to 2010, which I thought was fascinating because the financial crisis was right in there. Okay? And so what it has is a collection of about 3.5 terabytes of data for about over 1,000 products. Okay? And it was collected across 20 metropolitan areas for a large variety of goods, and I have information, more information than I can digest. At the end of the day, what I care are two variables, that, the unit price and the quantity of units sold. Okay? So just to give you a sense of how this data looks like, this is product 5001. I'll tell you later what 5001 is. So inside 5001, this is category 5001 for year 2010. I would have 6 files. Okay? And each, so take the first file is about 2 gigs big. And these are they are structured in the sense that it is in rows and columns. But it's not like you can download the data and immediately work on it. There's a lot of work you need to do to clean, okay? And I'll explain later what's going on. Okay? So what's particularly interesting to me is that I have transactions data. These are no longer synthetic price and quantity variables that are constructed like our national accounts. Okay? So we know exactly how much people pay. We know exactly how much people consume, how many units people buy. And initially, I have 260 weeks, which is 5 years of data. And in this data, the units, or the columns, so to speak, if I line up the data rows, the weeks, the columns are actually the store UPC. A UPC is the barcode. Okay? So if I buy a can of Coca-Cola at 7-Eleven, that's one store UPC is 1 unit. If I buy the same Coke next door at Walgreens, it's a different unit. That's how you see that all these, there are many thousands and thousands of these store UPs. When I first looked at the data, I needed a category that was small enough for me to kind of play around with, and I choose X. I thought, how many X can there be, right? And it turns out there were like thousands of X by store UPC code. And because, you know, if some guy brings his organic eggs in his farm to sell, that's, you know, in New York. That's one UPC, and then another guy from Pennsylvania bring his organic eggs, so that's another X. So I ended up having thousands of eggs that, without knowing whether they are small, medium, or large, which is what I usually know. Okay, so my interest really was in the Great Recession, because I have weekly data. Okay? We know the timing of events of the Great Recession, you know, pretty well, and I thought, well, you know, let me see what I can do with this data in terms of understanding the cyclical component of the data. Okay, so back to the first graph. Okay, so the housing starts. I see a big dip in 2010. Should I expect to see a dip in this spending in the Great Recession? Well, maybe not. My hunch is that it should, because everybody knew that there was a lot of nervousness around 2008 and 2009. So it would be really interesting to see if people actually contract their spending during that time of heightened uncertainty. Okay? So fast forward a little bit. I first wrote this paper 2 years ago for the World Congress, and at that time I had 260 weeks of data. Now I have 469. It's a typo. It's not 269. So I now have about 6 terabytes of data. And I actually did learn something from 2 years ago. So I'm actually giving you some updated stuff that I don't recommend doing anymore. Okay, so a typical series is this. Okay, so this is actually category 5001 that I showed you earlier, and it turns out to be beer. And there are 3 categories of beer, and since I'm not a beer drinker, I have to think very hard what I'm looking at, which is actually a good thing. So the top 2 graphs, on the left-hand side is actually the sales of a particular store, okay? Store UPC. Okay? On the right-hand side is the unit price of the beer sold by that store. Okay? So what you see on the right-hand side is actually infrequent movement or discrete jumps in prices, which is a phenomenon of great interest to macroeconomists. Right? So the question is, why aren't prices adjusting all the time? Why are prices changing so infrequently? Right? Because if prices don't change, it's not adjusting, it's not providing the equilibrating mechanism for the market to clear. Right? So you can ask a famous example for it. When was the last time Boston Globe in the newspaper box? When was the time that price changed? It's always, you know, you put in, it has been the same price for a while. So the same phenomena showed up in this data. Okay? So the top graph, it's not obvious to you. You see any big dip around 2008, 2009. Right? The bottom 2 graphs to your left, to that one, the far side, is aggregating all the stores for beer. So that's the aggregate sales of beer, so to speak. And what you see, what is most immediate, is the strong seasonality. Okay? What is seasonality? Well, we buy a lot of beer for July 4th. Okay? So that is the July 4th spike. Okay? And there's a next spike that is Memorial Day, and those are the 2 largest purchases. Okay? Now, if I'm interested in the business cycle component, I really cannot do anything until I take care of this data, this seasonality. Okay? And this seasonality, if I had used conventional data, would be taken care of by the government. right? Because it's no longer official data, so now this becomes my job. I'm now Mr. Clean in cleaning this data, right? And so here is the sales. So sorry, this is the price. You see price goes up, okay, which is not too surprising. We do expect prices to go up. So what you see is that the price at the firm level, which is the top, and the price at the aggregate level, they differ. Okay? One moves rather infrequently, and one moves rather continuously. And this particular issue has generated a lot of interest by economists in trying to understand this phenomenon. Looking at the quantity side, at least in using this data, is much less studied, and I've always wondered why, and this was precisely why I thought I would take a crack at it, because everybody has been looking at the price, so I thought, why don't I look at the value and the quantity? And now I understand why. Because if you look at the value or the quantity, you have to deal with the seasonality. If you look at the price, you don't, okay? So I have not seen anybody look at quantity like this, so this actually got me interested in it. So this is one series, so let's take a, so one question you can ask is, I don't think I can eyeball a cyclical component, a dip in 2008, much like the housing start series that I showed you, okay? So I thought, well, maybe it wasn't, maybe, and there actually is studies for it, maybe people get stressed out during recession and they actually don't restrict their consumption of beer. That was how one story goes, okay? So I thought, okay, so let me take a look at wine. Right? Wine, to me, would be like a luxury good. Well, it still wasn't that obvious, okay? But you still see a lot of seasonal variations, okay? But in this case, the seasonal variation is actually in November and December. We drink more wine during Thanksgiving and Christmas, but, so the point here is that even within the alcohol and beverage category, there is a lot of seasonal variation, but it's heterogeneous, okay? Each product has its own seasonal effects, and you cannot find a broad-based way to remove them in an obvious manner. Okay? Now, here, in terms of price, the wine price actually went up. So you have to factor in how this change in price affects the value on the left-hand side. Okay? And now you also see that compared to the beer, firms actually change the unit price of wine more often. Okay? Because compared to the previous graph, there were only two discrete jumps. The third one I'm going to show you is pet food. Again, because I don't own a pet, so I have to look hard what I'm looking at. At the individual level, the discreteness of price change is again very evident. Now we don't have a seasonal effect in cat food, which makes sense. Cat has to eat whatever season it is. But do we see a cyclical component? Not so obvious, So I had expected a bigger dip in 2008, and maybe I have to factor into the fact that the price of cat food was actually going up this period, so maybe quantity wasn't actually going down that much. And again, because I know little about the pet food industry, I have to search and see what should I expect of this series. And actually, there's some documentation that cat food is actually recession-proof. Okay, so people care about their pets a lot, and they actually don't cut back during recession. Okay? However, towards the end of the recession, there was also documentation that there were a lot of abandoned pets. Okay, so people cut back on different types of spending during different phases of the economic cycle. Okay? So my task, if I want to look at the cyclical component across a large number of series, is that I have to deal with the heterogeneity or variations, if you like. And I think computer scientists talk about the 3 V's. So this would be the variety. Okay? I have to look at the variety across goods. Okay? I have thousands of these series. I cannot babysit each of these series. I have to do this in a systematic, algorithmic way, if you like. And the question is, do I have any chance of extracting out the business cycle component out of it? Okay, so I told myself, well, I'm not the first one to use this type of data, but in the past, people have usually looked at one product. Okay, so this is mainly by people in marketing science. They may want specifically to look at detergents. Okay? So they only look at one product, and they can analyze in fine detail one product. Okay? But they're not asking the same question I am, which is the aggregate component. Okay? It's a separate question whether such a component is of any interest, and I'll go back to that a little bit later. And in economics and econometrics, there's a lot of interest in big data, but the question is always evolves around a model selection problem. In other words, if I want to make a prediction about, say, detergents, I have hundreds of variables that might explain the evolution of detergent. Which variables should I use to predict detergent? In this case, I don't have the luxury of many predictors. What I have is the luxury of a lot of information in the cross-section. I have lots and lots of units, okay, over 469 weeks. Okay? So I'm looking at I'm intentionally looking at a problem different from what others have looked at. So another way of thinking about it, often when we do empirical work, we only report results assuming that a data set is given to us. I want to step back and ask, what is the prep work? What is the work behind preparing this data set before I can even do any regression, do any estimation? Okay? So I want to look at so there's a lot of discussion about data science. I want to look at, well, why do we need data science? I'm an econometrician, so what's wrong with my econometric methods? Do I need to how far can the econometric methods take me? And why and why not? Okay? So that leads me to what I want to show you, which is that what I learned, what did it take me, what is the effort I've put in, successful or not, in trying to back out this cyclical information from this data. Okay? And there's a second question I look at, which is how much data do I really need? Okay? I have 7 terabytes, right? I probably don't need 7 terabytes of data, right? So, and even if I do, I don't probably, if I was to do a regression, I probably don't need a whole lot of information to do a regression because I don't do a regression once. I usually have to do a regression thousands of times before I can find the right specification. Is there a way in which I can work with a sketch of the data? So that was the second question I looked at, but I doubt I would have time to say much about it. Okay? So now I'm more in that camp of statistics and econometrics, okay? Which is the way I was taught, and it's the way I'm teaching my students. You start analyzing data by writing down a model, specifying a probability model, write down the distribution, you write down the likelihood, you write down the moments, you maximize the likelihood to find the parameters, and then you evaluate how good are your estimates by looking at the bias and variance, and we develop beautiful asymptotic theory for it. Okay? Then there's this other branch of method that is becoming very popular, and the more and more job market papers that would come up. We're in the job market recruiting season now. There are more and more job papers that tell us they're using machine learning methods in their thesis. Right? So what they have is a more algorithmic approach that they don't write down a model. You replace likelihood and moments by trees and forests. And instead of our traditional way of evaluating how good our results in terms of bias and variance, we're now into worst case error bound, which for someone with more econometric training, it's still very hard to grasp how does this worst case error bound translates into, is it good for what I need to do? And that remains my biggest concern. And I think that perhaps the biggest draw in favor of this new way of doing data analysis is that it usually has a downstream use, whereas the old way, even the existing way, or the way econometricians like to do it, is we emphasize on the beautiful theory, and once we do the theory, it may actually not be of as much practical use as we want. So what I do then is I start with the traditional way, and I see how far I get in order to get a handle on what in this slide is the C component. Okay, so the traditional modeling way is to write down a model. In this model, if I observe a series ZT, I can decompose it into many components. There's a trend component, there's a cycle component, which is the one I'm interested in. There's a seasonal and there's a holiday component and there's a irregular component. And really, I'm interested in just a cycle component. But I don't observe anything on the right-hand side. Okay? So I have to write down a model in order to separate out all these components. Okay? So as I said, there's no more Bureau of Labor Statistics, Census, or Statistics Canada that would do the job for us. Because if there were, they would have given me the data for ZT equals to tau t plus CT, and then the other three components would be gone. Okay? So the difficulty now is that I have all these components, and I only care about one bit. Okay? So it's interesting to ask, well, what is so difficult about adjusting this scanner data, seasonal adjustment of the scanner data? Well, the difficulty comes from the fact that we are in a Gregorian calendar, and we're in a 400-year cycle, and the weekly data is not exactly periodic. Some year we have 53 weeks, some year we have 52 weeks. Christmas is not always on a Saturday. My weekly data is always collected on a Saturday. Okay? So if I have monthly data, I can simply look at the difference between this December and last December's value, and the difference would kill off the seasonal component. But because my data are not exactly periodic, I don't have this luxury anymore. Okay? So I think this actually still creates a problem for algorithms, because this issue of not exactly periodic you're no longer in a routine setup that you can get an algorithm to take care of this for you. And I'll tell you how I cheated to get around this problem. Okay? So this reminds me, I was telling Neil earlier, this reminds me a little bit of the micro-market structure noise in financial data. It's just a high frequency data, a lot of noise, and there's still lots of work to do. Okay? So this is my first crack of looking at the data from a modeling perspective. And essentially, if you don't look at any of the equations, the seasonal component repeats itself, so we can fit it with sines and cosines, and that will take care of a lot of the variation. But you still need something random, right? So the way the government do it is to fit that random component with a fancy parametric model, ARMA model. Okay? But it's easy when you only have one series to do, and it's hard when you have lots of series to do, because each of these models need a lot of tuning. Okay? Nonetheless, I did give it a try, and I also added additional information, collecting data down to the county level rainfall data, because temperature and rainfall has got to be seasonal. Okay? When I look at individual series, my seasonal variations were gone. I was really quite excited, right? So I have my home-baked methodology that really cleans off a lot of the seasonal variation. Unfortunately, once I aggregate all the data back up, look at the aggregate component, the seasonal component pops up. So what this tells me is that if I'm interested in an aggregate component, the bottom-up approach simply does not work. I cannot work down from the product level and then aggregate up. Somehow I have to find some other way to kill off this seasonal variation at the aggregate level. So the next thing I did was, instead I abandoned the econometric methodology because it wasn't getting me anywhere, and I just went with the algorithmic approach. So what I then did was I aggregated all the data back into 117 products from thousands of little categories. So what this means is that instead of modeling cookies and potato chips, I simply model snacks as one big category. So now my data matrix is 469 by 17. It's no longer big. If you're curious what is the biggest category in my data, it's soft drinks. We buy more soft drinks than anything else from this database. And the second idea, which seems to work really well, is actually to make use of the idea that the principal component is actually going to find for us the components with the largest variation. So if seasonality is really such an important component, principal component should be able to pick it up for me. Okay? So that turns out to work really well. If I simply apply principal components, which is, you can think of it in machine learning as a dimension reduction method, simply apply it to my now highly aggregate data. This is what I would get for my first 8 components. Okay, so the first component is a trend. So you read top left, top right, like so. So the first one is this is in terms of the value. So you see value goes up over time. And you see that there's a lot of seasonal variations of different shape. Okay? The dominant variations, 40% of the variation actually comes from the trend. Another 22 from the second component, which is highly seasonal. Now, if I have to look for the cyclical component, or more specifically, I'm looking for a dip around 2008, which I know is where the financial crisis is. I see something in the fourth component, which is second row, second column. So that it is there, but it still wasn't good enough for my eyes. So I said, well, why don't I difference away this seasonal variation? And this is when I cheat. Okay? Because I have 1 year with 53 weeks. I cannot actually take the 52 difference. So the 53 weeks happen to have a Saturday on January 1st. So I cheat a little bit and just add up, make the 53 week 52. I haven't figured out how to deal with it yet, but now this is looking better. Okay? I would attribute the first two components still to these holiday events, such as Easter or Thanksgiving not falling on the same day of the week. But if I look at the third component, okay, it's not big. It's only 7% of total variation. Now it's looking like what I expect. There's a dip. Okay? So I follow, dig into this a little bit deeper. I said, well, if this if the data, if this scanner data represent people's actions, do they line up with people's intent? Right? So I got a hold of data from the Rasmussen index. Okay? Rasmussen is a survey firm. They actually do telephone surveys daily at 9 o'clock in the morning, and they ask people, how do you feel, type thing. And they ask a question for consumers, and they ask the same question for investors. And they kindly let me look at this data, and when I plot one over the other, I must say I was pretty shocked how nicely one mapped into the other. The red one is the Rasmussen index. The blue one is the cyclical component that I back out from this data. So what this tells me is that there actually is a cyclical component in this data, but you have to work pretty hard to find it. Second, this component is not very big. It's only 6%. Okay? So it's a fair question to ask, is this component useful? Okay? So I imagine if you were a consulting firm trying to sell, trying to publish information, there would be people who would be interested in this type of information, because this is real-time data, and it's telling us when people feel down, as in 2008, and that happens to be in November 2008, week 48, which was, that week 48 was when the government bailed out Chrysler and Ford, I believe. Okay? So there is information in the data, but you have to work very hard to get at it. Okay? So I want to repeat why I think this is, there's a lot of work that is, it's not like you download the data, you get your 7 terabytes, you find a big enough computer to digest this data. There's still a lot of things we need to think about, because this data is very, very, very heterogeneous. Right? And there's no way around aggregating up. And having gone through this exercise, I now appreciate why most people have worked with this data, just aggregate in some dimension into something that at the end of the day, you are no longer in a big data environment. You started with a very, very, very big, gigantic data set, but you aggregated a lot of it. Okay? There's a lot of experimentation involved. I cannot honestly say what I tried was optimal in any classical statistical sense. I feel like I'm abandoning a lot of my optimality criterion in favor of simply feasibility, because I was just happy that I could do this. A lot of judgment is involved. And one thing I'm also quite worried about is so traditionally, replication is, I value being able to replicate my results a lot. So many steps are involved in doing this, I don't even know how to write up a replication file. Okay? So I think, going forward, using big data for research, this is an issue that worries me. In terms of econometric implications, since I'm an econometrician, I also think there are different issues that pops up when we work with this data. When I have when I aggregate up this data this way, starting from billions of observations back down to about 500, I don't know how to think about the sample size. Okay? Usually when the sample size is small, I think about small sample bias. Do I now think about 500 as my sample size or the millions of observations sample size? I was asked to wrap up ASAP. So anyways, there are lots of fancy methods that we have spent a lot of time developing, but none of them really are very useful here. There's actually a lot of noise in the data. The last thing I want to point out is that we have a lot of data, but the data is not going to tell us a question. So if you were a student doing research, I think it is very important we think hard about the question, because you're always busy doing something when you do this data, and it's not clear you actually learn a whole lot. So my main lesson learning this is have a question very clear and know what you're looking for. Otherwise, you're looking for a needle in a very, very big haystack. Thank you very much.